I'm kind of torn on this question. Part of me realizes that the more traditional way to do this is not that hard, but I really just want to go to Desmos. So here's the most important thing is you got to recognize what the question is asking, right? One of the two equations in the system is a linear equation is given. The system has no solution, meaning these two things are going to have the same slope, right? Because they're lines. We don't have to worry about the discriminant or anything like that. Same slope, right? They're parallel. What could be the second equation in the system? So I could just rearrange these to get the slope, but notice that all the equations are kind of like in random formats where like the x is by itself for some weird reason. Like, I don't know. I'm just like, this seems like it's going to be a pain. So instead, what I'm going to do is I'm going to just go to Desmos. And I'll show you how to do it afterwards, but I would just say, all right, 3x equals, 36y minus 45 gives me some sort of line. So I'm going to keep that one, and then let's type all the others. So x equals 4y. No, clearly those are not parallel, right? They have one solution. We can see it right here. So no good, right? So that gets rid of A. Let's do B. So 1/3. Gotta make sure you type it right. 1/3 x equals 4y. That's pretty good. So let's keep that, right? That looks like they're parallel. So maybe. Let's turn it off so it's out of the way. And then x equals 12y minus 15. Now, those are clearly parallel in that they have the same slope, but you can see if I turn it on and off, that's the same line. So that is not a no solutions situation. That is an infinitely many solutions, and that's not what we're looking for. So this is definitely a little bit of a trap. They know that if we were to find the slopes, we would get this wrong. And I'll show you how we would prevent that later, but let's just move on for now. So that's gone. I'll leave it on just in case we need it later. And then 1/3 x equals 12y minus 15. Again, they clearly intersect. So that's it. That's got one solution. So that's it. Now, I don't know that that's the most efficient in terms of time, but it's certainly the nicest in my brain. I know what I'm looking for. I'm literally just looking for like, ooh, these two lines go in the same direction. It's very stupid, but it's nice. It doesn't require a lot of thought. And then I can get a question right. That's, I don't know, number 16. It's supposed to be pretty hard, but I don't have to think about it too hard, right? So that's probably what I do. But let's look at what we are supposed to do. And, maybe Desmos doesn't work for some reason is I would really want to get y equals mx plus b. So I would have to rearrange this first equation. I would do it by adding the 45 to both sides and then dividing everything by 36. So that gets messy because then I'll have y by itself and I'll have 3 over 45x. So that I could reduce that slope, but for now, let's just, keep 3 over 36 as my slope. And then the plus 45 is also going to be divided by 36. So that might matter later when we get into the infinite solutions thing. I've got to keep track of that y-intercept, and it's a messy number. They're both messy numbers. So this really reduces to 1 over 12. For now, that would be the thing I'd be like, I want to see a 1 over 12. If I divide by 4 here, right, this slope is 1 over 4, so no. If I divide by 4 over here, it's the same as multiplying by 1 over 4, so that's going to get me my 1/12. So, okay, so 1/12 x equals y. So that's good because it is the same slope, and since there's no y-intercept, I don't really have to worry about the fact that this 45 over 36 is some sort of kind of annoying number. I'm just like, well, it's different than 0. So good enough. And that would be enough for me to pick that answer. So it ends up being fine. But if I did the same thing on C and I start moving things around, this is where things get a little risky to me. So I'd add the 15 over, I divide by 12. So I'd end up with, I hate writing the y on the right side, but fine. Y equals x, or 1/12 x plus 15 over 12. And so the slopes check out, but now I'd have to evaluate, is this the same as the y-intercept up here? And so 15 over 12 reduces to, they can both be divisible by 5, or by 3, so that's 5 over 4. These can both be divisible by 9, so that's going to be 5 over 4 as well. So 5/4. So they are the same y-intercept and the same slope, meaning they're the same line. So that's no good. This is infinite solutions. We don't want that. They could ask for it, but they didn't want that here. And then if I did the same thing in D, I can kind of skip the y-intercept piece because I would just divide by 12, which is the same as multiplying by 1 over 12. So this slope is 1 over 36. And so not the same, so wrong. So I don't know. What do you think? Am I making a bigger deal about all this algebra? You know, some of you might even be able to see it without moving things around and getting into y equals mx plus b, but I think that's its own risk because I know the SAT definitely creates equations where you're like, oh, if I just do this, it'll give me exactly what I want. But then you forget that there's some sort of negative or some sort of distribution or something. And I don't want to open the door to that trap. So I just really like the visual. Let me just see it, right? Is really what it comes down to. This is nice and pretty, different colors, moving in the same direction. If I can use Desmos to not use my brain, I'll take that. I'll take that as a win.